pleasure to welcome you tonight and to see such a big crowd. Obviously the topic is of great interest to people, so I'll briefly introduce our speaker and then leave you to enjoy the information. First of all, we'd like to acknowledge that we're meeting on the land of the Kulin Nation and to pay our respect to their elders, present and past. And this is the monthly discussion group for the organisation called Beyond Zero Emissions. And we'd like to thank the University, Energy Research Institute and Zero Carbon Australia project partners for hosting this discussion in this place. For the people that haven't been here before, Beyond Zero Emissions is a climate change solutions think tank. We are involved in research and education. And our goal is to transform Australia from a 19th century fossil fuel economy to a 21st century economy that's powered by clean, renewable energy. And the projects we've done form part of a big project called the Zero Carbon Australia project. And in that we publish plans for specific sectors of the Australian economy. We have Retire Australia talks, we have meeting work, we contact politicians, have education programs and much more. And if you're looking for a group to volunteer with, then I suggest you have a look at our website or talk to one of us after this presentation. This discussion group is a chance for us to hear from experts about areas that are relevant to the work of Beyond Zero Emissions. It's my pleasure to introduce Peter McKernan. Peter completed a degree in electronics engineering at RMIT and an electrical apprenticeship at Fox Hill Technical College. He has completed training in environmental auditing and is a Clean Energy Council accredited designer and installer. He has successfully started and developed and sold 3 businesses. He's worked in professional audio, power rectifiers, television transmission, construction, mining, manufacturing, power generation and solar systems. Peter has been involved in the renewable energy industry since the early 80s. In the early 90s, this interest took him to the Middle East, where he demonstrated solar autonomy to people who had no grid. He has worked on a 500 kilowatt solar hybrid power system in Calabakan in Borneo, Papua New Guinea, and multiple remote area installations all over Australia. He spent 6 months at Casey Station in Antarctica, where he commissioned the synchronisation system for 2 500 kilowatt generators. And prior to this, he spent 10 years manufacturing houseboats at Lake Eildon, Victoria. And during this time, he developed a range of technologies that enabled these boats to become 5-star floating motels with total solar power autonomy. He is passionate about science and the environment and renewable energy. Ladies and gentlemen, please welcome Peter McKernan.
Thanks very much for that, John. Something John didn't mention is that I'm not a professional speaker, so if some of you have donated to the box in the front, there are no refunds. So what I'd like to talk about is a slideshow which hopefully will work. Good. So I want to talk about the future of solar and energy storage, and it is going to be a major power shift. There's 4 parts to the talk really. One's new sources of energy, the cost of energy, which will all get you really excited because I get to talk about your power bill. Talk about new efficiencies, and we'll talk about some future developments. First thing is the new energy sources, or what we'll all start to think of as energy 2.0. So around the world, the way we generate electricity, the way we distribute it and the way we use it is rapidly changing. And because I know I'm talking to the converted here, we'll get through this bit pretty quickly. So this type of generation and this type of transmission is rapidly being replaced by clean and efficient alternatives. Even the way we meter energy is changing. of all the energy consumed, all the embodied energy consumed in Latrobe Valley, about 11% of the energy makes it to the light globes over here. And where I live in rural Victoria, about 8% of the energy actually makes it to the light globes. All the rest is lost as heat. And so it's fairly easy to say that that's not a terribly good system and we need a better one. And it's happening everywhere. Right now, London has got the world's largest offshore wind farm. It's a 630 megawatt unit. That's enough for like 126,000 homes with air conditioning. I was surprised to find out that wind towers operate at about 36% of their nameplate rating. So that surprises me that, you know, the wind is so variable. You'd imagine that these things, if they produce their full output 10% of the time, you'd be excited. But the reality is the statistics produce about 36%. The world's largest solar system, surprise, surprise, is in a place called Gujarat in India. It's 600 megawatts. That is enough energy to power Geelong. In California, the world leaders in renewable energy, they've got the Desert Sunlight Solar Farm. It was the first plant in the world to reach 550 megawatts. That's enough power, to put it into perspective, to run about 110,000 air-conditioned homes. And Americans consume energy like only one other country in the world, and that's Australians. The UK has a fairly large solar system now. They've got a 46 megawatt unit. The UK has about 2.8 peak sun hours per day on average. Here in Melbourne, we look at about 4.5. Where I live, it's about 4.9. And yet London considers that it's well worth their while putting in 46 megawatts of PV. Africa has a wind farm, 301 megawatts. It's just off the Moroccan South Atlantic coast. That's enough power for about 36,000 homes. Mount Signal in California, power for about 72,000 homes. Off the coast of Western Australia, we have the CETO 5. This is an Australian invention. Australia has for a long time been world leaders in renewable energy, and this is just another one of the examples. This system uses the movement of these buoyant floats to drive a pump. They take water under extreme pressure to the coastline, where they run it through a turbine and generate electricity. And because the water's under pressure, it can be pushed through a reverse osmosis plant, and that same water can be used for making desalinated water. So you can see there's like a 2-for-1 advantage with that system. In Scotland, off the coast of Orkney, they've gone ahead and produced a 750 kilowatt wave generator. It just lays on the water surface like a giant snake. It has flexible joints, and as the waves pass under it, that motion is converted into kinetic energy, which is converted into electricity. The linear Fresnel solar concentrators have become quite a developing technology. Linear Fresnel arrays have been around for quite a while, but recently they've really started to produce large amounts of electricity. So by taking the water up to 545 degrees, you've got everything that coal can do with none of the emissions and, of course, none of the feedstock prices. So this sort of system can directly replace the boiler on a conventional coal-fired power station. The next generation of the linear Fresnel arrays, they're talking about 900 degrees is the off-water temperature, which will be quite a thing. And the concentrated solar. Now, there's quite a few BZEers here, and you all know about concentrated solar, so I won't have to bang on too long about this. But the important thing here is that, unlike all the other renewables, this one comes with its own storage system. There's at least 17 hours of storage in the tanks. So the solar's pumped up at around about 300 to 400 degrees sea up to the tower. The tower, obviously all the mirrors concentrate the temperature of the sun onto that one location. It raises the temperature, depending on the system, as much as 600 or 700 degrees, and then that heat is stored in a hot tank. When you want to generate electricity, you simply take the hot salt from the hot tank, pass it to a heat exchanger, immediately vaporise steam, and then put it into the cool tank. Because you've got the storage of the hot salt, you can just keep doing this all night, long after the sun has gone down. So 17 hours of storage mightn't sound like a lot, but given that the thing can produce energy when the sun's shining, you only need enough to tide you through the night, so 17 hours is more than enough. Some interesting statistics. Coal-fired electricity delivers about 11% of the embodied energy to the appliances. Solar panels deliver about 16%, and I've heard the power companies saying, oh yeah, solar will be good when they get efficient. Well, 16% is not bad compared to 11. And you have to realise too that that 16% is actually delivered directly to your home, or else it goes through your meter and gets delivered to your next door neighbour's home. So there's not terribly much loss in that system. As I said earlier, wind turbines can deliver as much as 39%, which is quite a surprising statistic. Solar panels, I've heard the rumour that they'll never repay the embodied energy in the solar panel in their lifetime. I found no less than 8 doctorates written on this subject, so I've averaged them for you. And they've come up with approximately 1.1 year for a polycrystalline panel and about 1.7 years for a monocrystalline panel. So really the repay period does seem to be fairly convincingly proven to be quite short. Wind turbines, the most surprising of all, can repay all of the embodied energy in 5 months. Blew me away, but it seems to be a fact. I've checked it many times. I've used the gospel according to St. Google, and that does seem to be the agreed figure. Coal-fired power plants, not sure if they ever pay back their embodied energy, and certainly they'll never pay back the energy in the feedstock. So I think the future of coal might be on the ropes. In June and July in 2014, Germany produced more than half of its energy from renewables. In actual fact, it peaked at 62%, which is amazing, given that we used to bang on about it'll never replace base load. Well, clearly it seems to be replacing base load. Australia was once a forerunner in solar penetration. We've slipped back to 29th. A little bit embarrassing. We've done no real large-scale solar in this country. We've got more potential to do it than any other country, really, but we don't seem to have the political will to drive it. Rooftop solar systems have an average return of about 18%. Right now, interest rates are fairly low. My brother just bought a car and he financed it at 2%. If you can get an 18% return on your money, I think you should just all race out and get yourselves a solar system. And by the way, it's never been about the feed-in tariff. So a lot of people are very disappointed to hear that it's fallen to 6 cents for your feed-in. Don't let them have it. Keep the power on your premises. Burn it yourself. If you burn it yourself, it's worth 32 cents. If you let it out the door, they're going to give you a measly 6 for it. Until we start getting better recognition for the power of generating diversified power, we're not really interested in letting them have any of our energy. Something that's quite probable in the future, if we get the political will, is a thing called virtual net metering. I really hope they bring this in Australia. With virtual net metering, you might live in a flat in Carlton, and it mightn't be an option for you to put PV on. But what you would be able to do is buy a share in a PV farm out at Bendigo, and thanks to the wonders of the World Wide Web, the energy that your share of that solar farm generates all the way out at Bendigo can be offset against your power bill. And so virtual net metering, which is already present in places in California, Mexico and the Netherlands, is a probable thing for Australia. So the first conclusion is that baseload sized renewable energy, it's already possible and it's already happening. It's been providing continuous and uninterrupted power of clean energy all over the world. So the rumour that it'll never replace base load, I think, has been well and truly put to bed. Theme 2, the cost of energy. You'll all be able to get excited about this later, because the true costs of energy has been hidden down a dark hole. America's just recently leapt on the gas bandwagon. They've got more gas than they know what to do with. It's the new saviour, it's the new energy thing. It's so cheap and it's nearly free. And they thought their power bills would go plummeting, but it didn't happen. That red squiggly line, by the way, I love graphs. That red squiggly line shows you the average cost of their electricity. And all these lines down here are the spot prices of the gas. And you can see clearly that for some reason the cost of the electricity didn't go downhill with the cost of the gas. And in Victoria, a strange thing happened. Back in the 90s, when Jeff thought we were running out of money and he thought he better flog off the power stations, it was about $40.50 a tonne. Right now it's about $38.60 a tonne. In actual fact, it's less than that. So clearly, it's not the cost of the coal that's driven up our power bills. And a lot of people were really, really disappointed when that carbon tax was taken away. They said to me, "Oh, I'm hanging out. Once that carbon tax is gone, oh, power bills, they're just going to plummet." It didn't happen. A strange thing happened in 2009. I don't know if you can see the mouse cursor. Do you see the mouse cursor? No, you don't. Yes, you do. Yep. Look at that. Back about here, we had the GFC. But it just happened that at that time, the National Energy Monitoring Association was having their big meeting, and they were predicting where energy consumption in Australia was going to go. Mm-hmm. And at that point in time, they thought, well, it's been... The mouse is a bit weird. They thought it's going along this trajectory, so it's fairly likely to follow this trajectory for the next couple of years. But it didn't. It actually started to drop away, which obviously we had an economic downturn, so that might have explained it. But then they had another meeting about here. And at this meeting they said, well, we'll see it's here. We predicted it's here. I've got a good idea. Let's say it's going to be here, and it's going to follow this trajectory. Now, to pay for that trajectory, they've got these brilliant contracts that were written by government officials. And I was reckoning if you want a really well-written contract, get it written by a government official. And it guarantees them 10% for whatever they invest in the power lines. And so this is the gold that we're all paying for. So here we are right now with our actual consumption. And we've got enough infrastructure to supply electricity at this sort of demands. And that's cost us a fair bit of money. So when you pay your power bill, 25% of it goes to the cost of generation. All the rest goes to distribution, transmission and retail. So not very much of your power goes towards the actual cost of the coal. And the coal, in the days of the carbon tax, it was costing a coal miner around about 8%, roughly speaking, to pay for the carbon tax. So if you take carbon tax, if you take 100% of your original bill, have a look at 25% of that, because that's the coal component. Take the GST off that, have a look at what the 8% was worth, and you end up with 1.8%. So when people found that their power bill had gone down by $20 a quarter, you can understand why they were disappointed. Really, the carbon tax was not costing us very much at all. And if you have a look at Australia's emissions figures since the removal of the carbon tax, guess what? There's another graph and it looks sick. I didn't even bring it. So the United Nations has said that demand for energy sources is a bit of a mixture, but one of the things that's fairly clear is that coal is on a bit of a decline. And they think that by 2043 there won't be very much use for coal in the world at all. The coal miners have fought back. They used to only have two models. They used to have black coal and brown coal. They've now got developing and unicorn. So they've now got developing coal. So developing coal is something that some politicians argue that without coal, poorer nations can't develop. We're concerned that with coal, respiratory health problems is the only thing they will develop. And the unicorn coal. Sorry, that's actually supposed to say clean coal. Clean coal is apparently good for the environment. It requires millions of taxpayers' dollars to develop it, and I believe you get it from unicorns. So, my second conclusion is we pay too much for energy because of really badly worded contracts. There's at least 7 corporations between you and where the energy comes from. There's a coal miner, there's a generator, and the generator's having a look at what we're paying for this solar stuff, and you can see what we're paying for sunshine, and they're starting to wonder if they're buying their energy from the right place. Then there's the high voltage transmission company, and he's on the plus 10, plus 10, plus 10 deal, putting in as much infrastructure as he possibly can. The low voltage distribution company's got the same contract. The line maintenance companies, if they can repair a cross arm or replace a cross arm, then that's a repair. But if they can upgrade a cross arm, that's an infrastructure investment, and that's worth 10%. Now there's an inspectorate. In the days of the SEC, the inspectorate used to inspect the electricians, and that was about the end of it. Now the inspectorate has to look at every single part of the power generation system and inspect every inch of it, and it costs us a fortune. And then there's retailers. Unfortunately, most of the retailers have got Alzheimer's. And if any of you have ever had a solar system installed and you've put in all of the appropriate paperwork, you'll notice that Alzheimer's has struck. And unfortunately, they've lost all of your paperwork. And on the 89th day, they write to you and they say, "Dear sir, we noticed that you'd like to have your system connected to the solar system. Unfortunately, one of the T's that you crossed or one of the I's that you dotted, we're not terribly sure if that's clear or not, so we'd like you to resubmit all the paperwork and we'll have another look at you in 90 days' time." And this is a fact. There's a guy that produces an article on this, and he's got no less than 27 reasons why retailers are avoiding paying for all that solar energy that they're getting and reselling to other people at 32 cents. What caused that turning point, and why is the country using less energy nationwide? Well, clearly these things are an obvious winner. Probably one or two in here. No, it's not. If I told you that I could save you 20% of your fuel bill by putting in a wee-wah, you'd probably all race out and buy a wee-wah overnight. If I told you can save 90% of your electricity by putting in an LED light, I think you'd get statistic shock. A lot of people do get this statistic shock and they hold off and they say to me, "I'll wait until the globe blows and then I'll replace it with the LED." And you think, there's no better payback figure. It's phenomenal. These things, if they're on for 6 or 8 hours a day in a shop, they can repay themselves in 5 months' time. And that includes the labour to install them. They're an absolute winner. Energy monitors are starting to take off. Some people in this room allocate their daughters 1 or 2 kilowatt hours per day, and they sit there looking at their energy monitor, and as soon as they've burned their 1 or 2 kilowatt hours, they're in trouble. Variable speed drives. These can make a massive difference to an electric motor. This is mostly an industry-related thing, but if you've got yourself a Fisher & Paykel smart drive, well then you've actually got a variable speed drive and you're already familiar with it. The idea is that electric motors will use more energy than they need to if they're not taught how to use it. And a variable speed drive will guarantee that you can use the amount of energy that is required to meet the load. And we've had savings of up to 64% for the installation of a variable speed drive.
Is that an inverter?
Yes.
Right.
Yes, fancy name for an inverter. So something that's happened across the world, and this is a US graph, United US Energy Information Agency, is you might notice that the amount of energy per person, which is the red line at the bottom, is starting to reduce. So clearly, although the population keeps spiralling onwards, we're actually using less energy per person. And importantly, GDP used to be linked to consumption of energy. And now you can see that for each dollar of GDP, we're using a lot less energy. So we've become more efficient overall. And in Australia, do you remember that turning point? 2009, when Australia started using less energy. Have a look at what Australia did in terms of photovoltaic installation after that. We've really started to ramp it up, despite our political aspirations. Storage has become big, and people are putting away, there's probably enough storage in there to keep somebody's average domestic consumption for about 5 days. This is an installation I did for a friend of mine. He's always wanted to own a power station. And now he can easily produce more than 21 kilowatts. He actually switches the grid off in front of his mates just to show that he can. And very few people realise, by the way, that Australia designs and builds some of the best inverters in the world. So these are actually Australian built, Australian designed inverters. And some of the people in this room will know that we also make some of the best regulators in the world as well. So if you did have some storage in your house, what you could do is you could start using energy early in the morning, and your solar could start offsetting this energy consumption. But then your solar continues on and makes more than you actually need. So you can pop that bit of energy there into a battery. And then later that evening, instead of buying from the grid, take that energy that you stored earlier and you use it. Now for the average home, let's say you're all 20 kilowatt hour a day users. There might be some tight asses in here that are down around about 12, but we don't want to know you. If you use that kind of energy, actually you only need about 6 kilowatt hours stored, because 6 kilowatt hours is enough to get you through the evening, and this means that your import from the grid is considerably reduced. So my third conclusion is that efficiencies are reducing our energy consumption. People are taking control of their consumption. New technologies like the lights, energy management systems, private solar systems, better storage, and clever load shifting. And economy-wide, this has resulted in decoupling economic growth from energy consumption, and that's a big thing. Now that we know it's decoupled, we've set it free. Let's see how quickly we can reduce our consumption. Theme 4, exciting new technologies. And I am excited about them. In fact, I wish the Green parties were as excited about the future as I am. All over the world there's new developments. So this is just a couple of headlines that I've grabbed in the last, since Miwa asked me to do this talk. And I won't read them all out to you, but you can see that just about anywhere you want to go, something exciting is happening in the world of renewable energy. And I think Australia is somewhat getting left behind. The flow battery is a fairly new innovation, although they've been around in some form or the other for a long time. Economic pressure has finally made them a reality, and now we're talking massive amounts of storage. These are big, heavy industrial storage batteries. And to give you an idea what they look like, there's one which is big enough to run a hospital off the grid. So you take the electrolyte out of one tank, you pump it past some active components, and then pump it back into the other tank and you discharge it. So these systems, there's various forms of them. There's zinc bromide and there's various other chemical forms of them, but they are a great way to store massive amounts of energy. And This is the one you're all waiting for. So you all know how good your lithium-ion battery, every one of you's got a DeWalt or a Makita at home, and you know how amazing those things are. Lithium graphene is going to blow the doors off that. I won't go into what they're doing in order to make this work so well, but the important statistic is that in theory it could have 20 times the charge density of a lithium-ion battery, which is phenomenal. They're talking about a 55 kilogram battery packing enough power to take a Tesla from Melbourne to Sydney and back again on one charge.
What's the battery called?
It's coming.
What's the battery?
Lithium-ion graphene.
Graphene.
Graphene, yeah. So it uses buckyballs, carbon nanotubes to... the first hybrid airplane is already using 30% less fuel than a conventional aircraft. Pilots are loving it because there's two absolutely independent motive forces on board this aircraft. It's got a petrol engine and the electric motor, and it's happy to fly on either, so they see this being a real safety thing. BMW thinks that 2015 will be the breakout year for electric vehicles, and they are aiming to offer every single model of the BMW available in an absolute plug-in electric vehicle as soon as possible.
What sort of battery?
Lithium-ion graphene, I hope. No, it'll be lithium-ion phosphate, but as soon as Elon Musk gets his act together, it'll be lithium-ion graphene. NVH is over, so those of you who know an automotive engineer will know that noise, vibration and harshness is the bane of all automotive engineers, not with electric motors. They don't make any noise. They reckon that riding in the latest model Tesla is just like having an amusement park ride. It's just super silky smooth and super quiet.
Dangerous for the deaf.
And dangerous for the deaf. Where does all this energy come from? Well, clearly here's a hail-proof shelter for your cars. Keeps your car out of the sun, keeps your car out of the hail, and by the way, while you weren't looking, it recharges your car. And how do you get the charge into the car? You use a tritium fast charger. This is another Australian company. Designed these units. They've done 1,500 of them in California already. They've been offered a contract to put a charging network from as far south as Byron all the way up to Noosa and then as far as Toowoomba. So you will have places to charge. The advantage of the tritium charger is that it allows you to dump a large amount of energy into your battery in a very, very short space of time. So you're not standing around for too long waiting for your car to charge it. They've already got trucks, electric trucks. At the moment it's only got a 100 kilometre range. It recharges in 8 hours, but it's delivering 5.5 tonnes of refrigerated product, so it's probable and possible. And there is a rumour that in greater metropolitan area of London, they're hoping to ban the internal combustion engine for 1 square kilometre. So this will be a real windfall for this type of vehicle. Meanwhile in China, they've knocked out a bus, 170 mile range, 180 kilometre range, sorry, with 120 passengers. Plug-in electric. And if you need a new car, you probably need a Tesla Model S. Price doesn't matter. You just need one of these things. 0 to 100 in 4.2 seconds. A range of 426 kilometres. There's already been 47,000 of these things sold. Time magazine voted this one of the best 25 inventions of the year. It costs $8.80 to recharge it. How's your diesel ever going to compete with that? Maybe you need to do a cappuccino run on this. This will get you down. Plug-in electric again. Range of 100 k's, top speed of 116. Maybe you want to impress the boys on Sundays. You go out on the 0 with equivalent of 298 miles on a charge. Some of these statistics come from the US and I can't be bothered converting them. But the important thing to notice is that it's $1.72 US to recharge it. And you can drive from some place called San Diego to some place called Los Angeles. and I think I want to do that. Maybe you want to break some records. The world's fastest production motorcycle right now, fastest motorbike out of a box, happens to be a plug-in electric motorcycle. It's the Lightning LS218 with 350.4 kilometres an hour. You'd need one of those. And for recreation, you'll need one of these. Range of 120 k's to 65 kilometres an hour. Can accelerate faster than a Porsche. If you're all going to buy the Tesla Model S, I'm going to race out and buy the Rimac. This will 1,088 horsepower. This will actually accelerate from 0 to 100 in 2.8 seconds. I can't have you all getting past me on the freeway. When I suggested to my wife I'm going to need one of these as a new work truck, she doesn't agree, but she did say this one might be the go, because apparently you can get a roof rack option for this one. Must-Star City. Did you notice I said Must-Star and not Mazda? The people that live in Must-Star City say Must-Star City. It's near Abu Dhabi. It's built around a university. That university is already operational and they're already working on lithium graphene batteries. They've got 45-metre wind towers in Must-Star City that bring cool air down into the city. In a place as hot as Abu Dhabi, you can imagine how amazing that is. It's 100% renewable energy. They're using 100% recycling in the construction of all of the building. So all the waste materials are being gathered up and 100% recycled. It will have no grid connection. And for zipping around town, you'll jump in your little autonomous electric car and it'll just take you to your destination. This is the university building here. Don't tell me you don't want to go there. So the final conclusion is that the way we produce and consume energy is rapidly changing. The future promises to be clean, green and very exciting. It's up to us to make sure that our leaders take us in the right direction. Thank you. I'm happy to take a lot of questions. Come on, Owen, walk in. Yes, Ian.
Now, I happen to have a solar installation
Oh,
at home.
yes.
I'm not quite sure which Peter McKernan it was that installed it.
Right.
But what's my next step now with regard to type of batteries that are in the marketplace for me to start storing?
Good point. The cost of batteries is plummeting. It's following a similar curve to the cost of photovoltaics. So when I started in solar, I used to pay $13.50 per watt. I can now buy good solar panels for 62 cents, possibly even less. Storage was about $350 per kilowatt hour. It's currently hovering around about $150 per kilowatt hour. Elon Musk would like to see it under $100 a kilowatt hour. The question is, do you rush in now and put in good quality AGMs or gels, or do you wait until lithium-ion graphene is available? The lithium-ion graphene battery to run your house will be much smaller, so it might have a much smaller footprint. It won't have the fire risk that some lithium-ion phosphate batteries have. But if you're in a real hurry, you'd rush out and put in some gels.
When's the lithium-ion graphene battery sound like it's on the market or likely to be at a reasonable,
So
luxury
the
price?
time from development to market on these sorts of things is really, really coming down. I can remember when the first triple junction solar panel was invented, it was like a 10-year wait for a triple junction solar panel to be on the market. With developments like this, I don't think they're going to wait. The demand is phenomenal. Elon Musk has just invested $5 billion in a factory to build batteries. It's called the Gigafactory, and he would like us all to believe that it's to It's to sell the lithium iron phosphate batteries, which he's in bed with National Panasonic, and so he would like you to believe that that's what they'll be making. And there's no doubt they will be, because the Model S currently uses those batteries. But we all believe that there'll be a lab there, and they'll be making lithium ion graphene.
If you've got solar panels now, how does it work that you actually, when the technology is available for the latest technology, lithium batteries,
Yes.
how does it work? You actually wire up, or get electricity wired up and you disconnect from the grid, or how does that fit in with the actual grid connection?
So what you have is what's called a hybrid system. Maybe I can just go back in time and show you maybe a photo of a hybrid system. So your installation is probably single phase, and so you've possibly got an inverter, something like that. They're a German-made Coco inverter. So what you can do is you go and buy one of these unbelievably good Australian designed and manufactured inverters, hybrid inverter, and then build a cabinet in which you conceal some batteries. And what happens is the energy comes off the roof as DC that you're already used to, and it gets converted to AC in your existing AC inverter. If it's making more than you need, then this thing makes a decision as to what to do with that energy. So it's possible for this to take energy from here, through here, and put it into the batteries. It's also possible for it to take it from here, into here, and put it out to the grid. If your batteries are flat and there's no solar, it can take some grid energy in, convert it to DC and put it back into your batteries. So all that is fully automatic, and that's like an add-on to your system. At the moment, Electronic, that make that inverter, are having a little bit of a problem with generic AC inverters, which is what you've currently got. But I think it won't be long and they'll have a stopgate solution for all inverters, and so you'll just simply put their hybrid inverter in place and your batteries. The hybrid inverters, these are about $7 or $8 grand each, and you need to spend about 5,000 on batteries. Yes?
I'm one of these people whose power bill is mostly the company charges me minimum rates. In fact, they cut us off because we didn't use enough power. I hate my energy company, but I don't see any better energy companies around.
Yes.
I would love to put solar on my roof,
Yes.
but my roof is too much of an interesting roof, so I don't have a lot of flat north-facing space
Yes.
in order to make it worthwhile. Now, we can't yet go for these networked options. What is the next best solution?
How old's your roof?
About 60 years old? 60.
60. Bit shabby?
It's tiles.
Tiles. Oh,
Lovely mossy
Yeah.
ceramic tiles.
definitely shabby. So one option with an unlimited budget would be that if you'd been at one of these earlier talks, we had a guy here from the CSIRO that had developed a printable solar panel. And so they are going to be building integrated. So they've got into bed with BHP, and you'd be able to buy tin from BHP, put it on your roof, and they have tiny little edge connectors, and you put the tiny little edge connector on and you'll start harvesting electricity. And it doesn't matter what the orientation of the solar panels is anymore. We're over the orientation problem. You just put lots of them on and you'll make lots of energy. So building integrated solar could be a solution if you need to replace your roof. If you don't need to replace your roof, don't be put off by the old adage that all solar panels in the southern hemisphere have to face north, because it's not true. If we go back to this graph here, if this is your home, and this is you with a kettle and toaster on first thing in the morning, and this is your hubby putting the oven on and doing a souffle in the evening, you can see clearly that your consumption sort of follows this fairly strange curve. If you've got a north-facing solar array, you'll produce energy pretty much like this. If you've got an east west-facing array, so you've got a whole group of panels facing east, you'll start to make energy a bit earlier in the day when you need it. And if you've got a western one, and it's a stinking hot evening, and you've got the air conditioner on, you'll be orientated towards the west. So when I was paying $13.50 a watt for a solar panel, I would have said to you, face the north, we want the maximum yield. But now they're so damn cheap, just stick them everywhere. Stick them on the garden shed, put them everywhere. Yes, sorry.
If all of us who have solar panels get batteries and turn off the grid, this is going to become a big problem for the people who can't go off it, isn't it? That's
Yes.
what worries me.
Yes.
Isn't it
My wife
more
pointed that out.
efficient in a community perspective to actually put all these solar panels on schools, on shopping centres, out at Bendigo, where it wasn't mentioned before?
Yeah.
And have big storage batteries, rather than lots of people having their own little individual systems which may or may not get enough sunlight, etc., etc. Wouldn't we be better off encouraging that sort of development rather than all doing our own little thing?
That's a bit of a philosophical one. I like it. My wife agrees with you 100% because she sees that as more and more go and abandon the grid, the only thing that the grid providers can do is up their ante for the few that are left on it, and that's unfair to them. The reason the internet was invented was because they thought mainframes were fairly vulnerable. I think of a coal station a bit like a mainframe. I think it's fairly vulnerable. And diversified generation, which is what we're getting now, is actually less vulnerable. If you keep the grid in place and you go hybrid, so I have the grid connected to my house, which might surprise you, and I use the grid like a standby generator. And once a week, whether I feel like it or not, I sip a little bit of the grid just to see if it tastes the same as it used to. The rest of the time we just don't use it. And but the good thing about that is that if my next door neighbours are a bit short on from power, we still have that infrastructure in place, and I do have a connection to them, and I do export power, so they are actually sponging off me. So I think there is a place for the grid, but it won't need to be upgraded for a long time, given how much money we spent on upgrading it recently. The population could grow, fivefold probably before we need to go back at increasing it. India has massive problems with their grid. It's very, very undersized and it collapses frequently. People see voltage variations down as low as 100 volts on a 230 volt system. What they've noticed in India is the more and more PV that goes into the system, the more stable their grid gets. So I guess there's pros and cons. Yes, sorry.
With grid-connected battery systems,
yes,
the battery part is not the biggest expense.
Yes.
Because we're getting prices, let's say 200, 300 per kilowatt hour battery.
Yes.
But when you do the maths, say 10 kilowatt system,
yes,
could cost you $3,000.
Correct.
But who's manufacturing or what's going wrong with the electronics, and how can we drop that part of the cost?
I see. You're saying like the $7,000 for the Cellectronic.
Yeah.
Well, that is coming down without a doubt. I've paid a lot more for those inverters in previous slides, and so the cost of the inverters is coming down. I mean, I feel for every Australian manufacturer that's left, and there's not many of them, that the competition that they're facing is phenomenal, and the support they get is zero. So these massive innovations, this massive amount of R&D have gone into development of a world-leading inverter, and they've received zero. But despite that, they're getting phenomenal sales. They sell into Germany, amazingly, and as the sales volume pick up, I think you'll start to see the price of those units plummet. I think also you'll start to see more integration. So at the moment, the installation's a little bit messy. We've got a DC panel, an AC panel, we've got a maximum power point tracker, we've got control of the batteries, we've got battery monitoring systems. All of that will start to just be one package soon, and so the installation costs will fall with that. So, yes.
So if your ordinary household, existing solar PV system, maybe averaging around 4 kilowatt hour rating, but not yet battery backup.
Yes.
Can you tell us clearly what's involved in putting that on now in terms of what sort of batteries? Will it still be lead acid? What sort of payback period? Did that picture where you had the 3 inverters mean if you've got 3 phase, you've got to do 3 of those and triples your cost?
Yeah, you do, yeah.
But
Yeah, sorry about that. But it's so exciting. Don't worry about what it costs. Just do it. We'll get alongside. Yes, you do need to, but sorry, as the gentleman down the front just pointed out, the cost of the batteries isn't that much anymore. What you may choose to do, and so the hybrid system started life as, think about Marysville, 2009, heat of fires, people with 5 weeks no supply. So a hybrid system got them through. And so the few people that had hybrids got through and told the others that didn't have it, suddenly we were putting hybrids in. And you might only have 5 or 6 kilowatt, you might have say 12 kilowatt hours of storage, of which we want to use 50%, so we only want to shift 6 kilowatts. Yep, 6 kilowatts is enough to get most people through. You know, you'll probably burn 15 to 20 kilowatt hours a day, but with 4.5 peak sun hours a day and a 4 kilowatt system, like you said, so you've got a yield of about 18 kilowatt hours a day, you'll get fine. Yes?
I wonder if there is any consideration about the life cycle of these batteries, if we're scaling up, or the issues about waste as they become redundant and go online, or they retain their lives.
Can I confess?
Would you repeat that? I think
Yes. So you're concerned about the life cycle of the batteries. Because the solar systems themselves have got a 25-year life. The oldest panel that I've got, I put in 1983, and it still works. It was made in Australia. We don't make them anymore. The batteries, here's my confession. We're all taught to talk after our batteries, lead acid batteries, 50% depth of discharge. You know what I think? Give them 70. Because new stuff's coming. Shiny new stuff that comes in boxes and you put it in there, it'll be so much better. So I reckon hammer the batteries, see if we get 7 years and then get the new shiny stuff.
Sure, what do you do with the old stuff?
Pretty
So
simple.
I'm saying I bring on batteries, I'm not trying to be
Yeah.
romantic, I just want to know if there's also consideration about the sustainability of heating technology.
It is.
Lead
Lead acid's a fantastic recycle capability. Lithium bromine, the liquid storage batteries, 100% recyclability. The lithium iron phosphate batteries are not quite 100%. So yeah, they are looking at it and also doing life cycle analysis testing. And in some more advanced nations on this planet, that's become an imperative. And they're actually driving the cost of the units. They're actually penalising people who don't consider those things. Sorry, yes?
Yeah, I was just going to ask you about your thoughts on the saline batteries that have been developed recently.
Another brilliant breakthrough, and allegedly you can drink the electrolyte. Heaven knows why we want to drink electrolyte. It's supposed to be very, very safe.
Very, very safe.
Very safe, low yield, and low maximum rate of charge.
Yes, but you can, if you don't have particular space constraints, and you've got a solar panel that's trickling in there all through the day, then there's no real disadvantage, is it?
That's true. That's true. I'm about to do.
If they're safe and they're relatively cheap,
Yes.
then are they coming on the market? Are they available for domestic? If not, when?
So the relatively cheap part is a theoretical thing. The actual prototypes are extremely expensive. So I'm about to do some lithium bromide batteries, and we're going to pay $10,000 for 10 kilowatt hours. So we're paying $1,000 a kilowatt hour, and we need 60. So we're going to really pay for these batteries. However, breakthrough technology always costs a bit upfront and quickly comes down. So if we can get some adoption of these things, which is why I'm encouraging it, you might start to see the saline batteries drop in price. Yes?
Lithium ion batteries like in electric car like a leaf, how are they going to react to this really high down fast charge? Doesn't that shorten the lifespan of the battery?
So heat is the only issue.
Could you repeat it?
Yeah, sorry, yeah, good. The question was, you know, fast chargers like the tritium charger, what damage does it do to the batteries? And it's absolutely true that it does shorten their life. The only thing that stops your cordless drill from recharging is heat. It's got nothing to do with voltage or current or how full the battery is. The only thing that stops it is heat. And that is the case with the Lithium Leaf that you're talking about. So the charger will provide as much charge as the batteries can possibly absorb, up to the point where the internal thermal sensors start saying, we'll peg back, that's enough. So it will shorten their life, but they obviously do that cost analysis curve and they find the sweet spot, you know, between the maximum rate of charge and the life of battery. Yes?
The inverters you had shown up there, how do they operate in terms of the buyers of that excess power?
Yes.
Like, do they automatically switch off in case of, you know, the situation? So I understood that the power companies don't want you having your own power,
yes,
which can then go into the
yes,
system if there's the power.
Yes, that's the fried linesman idea. So the linesman's up there fixing the line, he's pulled the fuse out. He knows this side's normally the naughty side, but he thinks this side where you live is normally dead, and he'd like to think it is dead. So you're dead right. The inverter is incredibly smart. It knows that the grid's not present, and I won't spend half an hour explaining to you how it works out that it's not present, but it knows that the grid's not there any longer. But it also knows that you're still there, and that your wife still wants to cook dinner. Oh, sorry, you want to cook dinner. And so it will provide you with energy and a contactor between your load and the outside world drops out. And in fact, when the grid comes back on again, it doesn't trust it. And for 60 seconds, it looks at the quality and the reliability of the returned grid, because it might only be there for a couple of seconds and disappear again. So it watches it, and when it's happy with it, it then synchronises your AC waveform with the incoming AC waveform, and once it's happy, it seamlessly reconnects.
And is the power company happy with that setup?
They're not happy with anything. Yes, they are. Yes.
Yeah, I have a follow-up question to the earlier one. What happens if everybody installs this? So if we get to a tipping point and it becomes very affordable and everybody has solar and storage and goes off grid, there will still be some people living in apartments or unable to afford the house that can't. And so these networks continue to exist, continue to be expensive to maintain and so on. So who ends up paying for the networks? There's a small number of people that
exactly as the other question I said earlier. You are dead right. It is a big problem. You know, I don't know where the solution to that problem is, other than if our government adopted virtual net metering. Well, then that's going to help everybody. Because with virtual net metering, everybody in this room could all buy a share in a solar generation system. And you all need the network to get the power from it, because you don't live where I live. I want my little bit of power, you want your little bit, so we need that infrastructure. And then we could perhaps pay a fair rate for transport of electrons from the farm, where it's been generated, to your place and to my place. That's not what we pay for at the moment.
It's a bit like having roads, isn't it?
Yeah, it is, exactly. Yes?
Take your virtual networking.
Sorry,
I'm just wondering whether you can get your virtual networking one next year. Where I come from India,
yes.
You mentioned India a couple of times. Would it be possible for the western part of Australia to have a large solar setup and transfer the electrons to India rather than shipping coal?
What are you doing when our next election comes? Yes, absolutely fantastic idea. Beyond Zero Emissions probably have written the most detailed plan of all I've ever seen about this. They've identified the logic of using high voltage DC as opposed to high voltage AC. You can get phenomenal ranges with DC transmission, and it's not new technology. Victoria and Tasmania have been linked by a DC feeder for years. So you're dead right. In the centre of Australia, we get so much sunshine we don't know what to do with it all. And we could easily power our entire country with nothing other than photovoltaics if we had the motivation. Yes, up the back.
So 2 questions. Just the first one about sustainability. So, you know, if the future's about lithium-based batteries,
yes,
clearly lithium isn't democratically distributed across the globe. In fact,
correct.
It's distributed in China and in some lakes in Bolivia.
Yes.
You know, is it going to work? I mean, it's huge enough to talk about it. When you try to scale up to a global, everyone buying lithium batteries, then there's just not enough lithium around, is there? Or low cost lithium anyway?
I don't know. I don't know at all. But you're dead right. This could be a major problem. I think that the pressure to develop storage and the amount of people doing research on this subject right now is going to come up with a plethora of alternatives. And if the lithium one becomes unaffordable due to scarcity, I think there'll be plenty of others that will just take it over.
Absolutely.
So Stanford have just come out with a research paper on aluminium graphite battery. And we've got plenty of, you can use your Coca-Cola cans.
Yes. Yes.
There's so much going on, and there'll be solutions.
In fact, there's a YouTube video of the guy lifting up his boot on his car and literally sliding slithers of aluminium into the battery to repower the battery.
The second question is, why don't we see enormous number? You're saying that the cost of solar panels has come down so far. Why don't we see an enormous number? We don't see any shopping centres in Australia with large numbers of solar panels coating the roofs. We don't see any large-scale industrial plants with solar panels coating the roofs. Why don't we see that? If, as you say, that the cost has come down so far.
We have a thing called an STC, which is a small technology certificate, and it seems determined and designed to cap all systems at 100 kilowatts. 100 kilowatts on a shopping centre wouldn't be a drop in the bucket.
Sure.
So, so it is a bit of a problem.
It's economically viable. You're saying that the cost of panels is very, very cheap. So why wouldn't we be seeing that?
But it's not a shopping centre.
While you're saying that, it's happening. It's just
they buy wholesale, sell retail. So they're under all their leases.
Yes.
Their leases dictate that they have to buy effectively. It's the Westfield model. That's how Westfield makes money.
Yeah. Harvey Norman's the same.
Harvey.
Yeah.
It's their leasing arrangement. Their legal leases.
It doesn't explain why large numbers of industrial companies that you see all through the suburbs and whatever don't have these large...
It is starting to happen though. I have to say, like NHP, which is one of Australia's premier electrical wholesalers, on their roof, in the shape of an N, a H and a P, they put a massive amount of PV. So it is starting to happen. In my area, I live in rural Victoria, there's no less than 8 30 kilowatt installations on caravan parks. And there's a couple of 50s. Our local hospital's about to pick up 100 kilowatts. So it is happening. There's building projects at Webb Dock right now. They're looking at 100 kilowatts. So it's starting to take off.
Every idea is just on a huge system as well.
Yes, sorry, at the back.
Just a couple of quick points. The largest commercial lithium mines in the world are in Western Australia.
Yes.
And last year was sold to China.
All right.
That's the point.
Great.
But I would like to talk about a holistic view.
Yes.
We're here beyond zero emissions.
Yes.
We're focusing on electricity, reticulated electricity.
Yes.
But our total emissions are a whole bunch of energy.
Yes.
And we have assets that are very important to our lifestyle. Power stations are one of them. The electricity grid's another. And the ability to transition to sustainable energy is very important, but it needs to be done in a holistic way.
Yes.
One of the things that have happened in the last couple of years is we've lost a number of major loads. Aluminium refineries have gone elsewhere. A couple of car companies are planning to shut down.
Yep.
Now, you talked about at the end of the thing about our leaders, when are they going to take us here? I don't think they'll ever will. We've got to take them. they're not leaders, they're followers.
Yeah, there's a fellow named...
Each person needs to take the right approach to convince them that if they want a job, they want to get with the program. And the important thing is to take a holistic. Our gold-plated energy system, reticulation system, is perfect. We don't have to import fuel, petrol, diesel, LP gas from Singapore, Japan, Korea, where they make the cars, and then truck it up and down our roads. We can have, if the government, instead of saying to the car companies, see you later, but they're still going to have to spend the $900 million to take them on, said, okay, you get the $900 million, but make hybrids with a CNG power source.
Yes.
And tax the petrol and transmit the energy through the power lines, the gold power lines, and then you have a system.
I've got to spend a long time.
Economy is energy.
I've got to spend a long time agreeing with you because we're obviously on the same wavelength. And further to what you're saying, clearly agriculture, tractors are big heavy beasts of things. Electric tractors are viable right now. Why on earth can't Australia make electric tractors? Why can't we just good at something? The world's leading country on wind farms is a tiny little country that really doesn't collect that much wind, but they're a world leader. We really could. There's a fella named Malcolm Turnbull. He carries a copy of the Beyond Zero Emissions energy plan with him when he goes to meetings. I've seen him carrying it. So there are some politicians who have read the document and do understand that transition's possible. And if they've read it, they'll know that for less than 3% of our GDP, we can fund the transition in 10 years. We can do it. It's viable and
we
it's
have
happening.
a much bigger GDP if we used our available energy
for
our benefit and transitioned it properly. We work on agricultural research and development functions. And one thing on a ute on a farm with half a dozen solar panels on the top and a 10 kilowatt drive. Most farm utes don't do more than 40k.
You're right, yeah.
And the torque in a 10 kilowatt DC motor is enough to pull a bull out of a bloody swamp, no problem.
Sorry, middle. For a bit of fun the other day, I asked for a quotation to put a solar system on my roof.
Yes.
It came in at just over $5,000.
How many watts?
It was just two-phase, I can't remember the number of watts, but trying to argue with the man, the price of the panels got nothing to do with the price of putting the system on your roof.
So
it's the iron and copper and
a really unfortunate thing happened in the solar industry, and it's just played into the retail companies' hands beautifully. And that was that the government decided, in their wisdom, marketing companies should sell solar systems. So unfortunately, we had this massive rush into the market of people who really didn't know what they were doing, but they were busy doing it and they were making lots of money and it didn't really matter. The good thing about that is the cost, they were driving the price. They were price-focused people and they were driving the cost down and it was spiralling. I can remember when $2 per watt installed was our goal. Right now it's about $1.50 a watt. But our goal is currently $1 a watt installed. They keep driving it down. So that means a 5 kilowatt system installed for $5,000. That's remarkable. The payback period, by the way, for that will be 2.1 years, which will be phenomenal. However, just pay a little bit more. Don't be such a tight ass. Don't get something that's not designed for you. Get something that's designed, installed, and guaranteed by somebody who's actually got some interest in that subject and really knows what it is they're selling to you. I've seen so many installations that were sold to people with marketing companies. I've arrived at the site to see the catastrophe that's happened, and they're staggered to find out that the floor heating that they've used and loved for years and years and years and used to have an afternoon boost on it suddenly disappeared. And the person from the marketing company didn't know that that was one of the preconditions of the retailer. So they've just been swamped into a system that was really inappropriate for them and it was poorly designed. So try and go to the Clean Energy Council website, find a Clean Energy Council approved installer and get them to do the quote for you. Don't get True somebody or Blue somebody or... Yes?
How many cycles do your the $200 per kilowatt hour batteries come?
How many cycles?
Yeah.
Okay, so cycles of batteries is directly proportional to the depth of discharge, it always has been. So if you discharge the batteries to say 10% and recharge them, you'd be looking at 8,000 cycles, which is a lot of years. If you go and discharge the battery to 20% state of charge or 80% depth of discharge, you can bring that down to 400 cycles. You can really, really shorten the life of a battery by how much you discharge them. So when my friend and I were talking about batteries earlier, we discussed the 50% figure. That's kind of the notional amount that you should discharge lead-acid batteries to. Your lithium bromide battery, your liquid electrolyte battery, you discharge at 100%. It's perfectly happy with it. So it depends on the technology in that regard. Yes.
There are some companies that are installing, designing and installing lithium iron phosphate hybrid battery systems now.
Yes.
Do you reckon that's a good option to go?
They're great. So there's quite a few. Siemens, ABB, there's heaps and heaps. And every year in October, early October every year, there's a thing called the All Energy Expo. And since all you people seem to be somewhat interested in energy, go to the All Energy Expo. You'll be blown away. There'll be like 900 stands selling solar panels. You'll see building integrated solar. You'll see hybrid systems ready to go. And they are getting cheaper. The packaged units that you're discussing usually have fairly limited handling. They're quite often a 3 kilowatt system with a 3 kilowatt load shift, but I have started to see some heavier ones. So ones that are designed more for you and I. Yes?
Shouldn't we be redesigning our transport altogether? Because really, railway is so much more efficient than road, especially here in Australia, where between Melbourne and Adelaide, you've got several hundred kilometres. Melbourne to...
This is the fast rail thing, isn't it?
Well, it's not necessarily fast rail. It's just that rail is much more efficient for stop.
Yep.
And we're getting rid of a lot of our railways rather than building them up.
Without a doubt, you know, if you go to places that have got good rail networks, I went to Japan last year, blew me away. It's just so nice. It's just everything's good about it. There's showers in them, for goodness sake. It's just, it can be done really, really well. And the good thing about it is that you don't need to use fossil fuels to power them. One thing that Beyond Zero Emissions has missed out on, whoever wrote the report, is some people live in the country, and those of us that live in the country, the only way we can get anywhere is in a car or on a bike or a horse. So we are going to need Tesla Model S's, but the rest of you can travel around in trains. Last question. Last one.
I don't know if you saw Catalyst a few weeks ago where they were talking about making gallium-based PV cells that big, that were equivalent to one that were 2 meters.
Correct.
2 meters.
Correct.
What's the potential for households for that kind of system?
That is really focused. So up at a place called Carlup in just south of Mildura, there's this amazing installation of 40 kilowatts of photovoltaics, and they are concentrated photovoltaics. So they've got huge parabolic dishes, and they concentrate the solar energy on a very, very small solar panel. Two things happen. One, it produces truckloads of energy at an incredible 41% efficiency. In fact, Australia just broke the world record, 43%. Big cheer, everybody. And they also make a truckload of heat. So what they're doing is they're passing a water jacket behind it. They're going to turn it into steam and use a Rankine cycle generator, and they're going to generate electricity as well. All we need is the right government, the right attitude.
We'll never get that.
And it'll just go like a truck. Actually, they've sold that installation. They were asked to put up 4 kilowatts. Forgotten the numbers. They don't matter. They were asked to put up a demonstration plant and prove its worth for 2 years. At the end of that, Arena was going to fund them for a massive increase. They got a similar deal in the Middle East. Put it up, we'll look at it, we'll let it run for 2 years, and if it does the business, we'll get you to increase it. They just switched the big one on. They just got the initial one in place in the Middle East, and the guy that's paying for it said, how soon's the rest going on? No waiting period, just do it. If that works, I'm convinced that's what we want.
Peter, I don't... To say, thank you for a highly informative, entertaining, full of information presentation, and people have anticipated that and really enjoyed it. And I think if you would like to continue this conversation or discussion, there's a meeting room or there's a space perhaps in the Clyde just down the road a bit for people who want to ask more questions or discuss it. Just a bit of housekeeping stuff. Beyond Zero Emissions runs on very little money, and our website will have a category called Baseload Supporters. These are people who offer to contribute a regular amount to keep Beyond Zero Emissions their research and their public information and presenting things like this. You can catch up on Beyond Zero Emissions on YouTube, where you may see and download slides that are relevant to your information. And if you like this topic, you may want to check out the podcast on the BKD radio program. And we have interviews about Tesla Motors and the Model S electric vehicle that's arriving in Australia, and also Sunverge solar battery and storage kits in California. That's on our podcast on our website. Our next discussion group will be Monday the 4th of May, and we'll be pleased to have a discussion and hear from Dr. Julian DeHoo from IBM Research and the University of Melbourne, and he'll be presenting electric vehicles and energy storage. What do they mean for the grid? Thank you for your attendance.
The APA, with one of its groups, is running an electric vehicle expo on Sunday night.
Right, thank you. Thank you. Thank you for your attendance. We welcome you